Here's Steven pushing his quad into the shop here. He's going to donate his 36-volt quad for the cause. We're going to pull it apart, put it in the 48-volt system. We already started with a battery, and that promptly cooked the controller after about one day of fun, prompting the entire teardown. Our first step is to flip the quad up on its back, revealing the battery drawer underneath, which is a fairly elegant affair. You pull in on these two tabs, and the drawer drops down, revealing, hey, lithium ion. Well, that's because we already did the battery step before we decided to make a full project out of it. 2 nuts and 2 screws free up the seat and the little control panel here, but there's a bunch of wires that will have to come off before we can actually get the panel out. I'm curious as to what's structurally holding it, so I'm just trying to figure that out at this point because I don't even know where it's attached. Looks like I'm going to have to go ahead and remove all this wiring if I'm going to get the quad's body off far enough to find out what's actually holding it. I'm not being especially gentle with the wiring because I don't plan on saving any of it. Whereas with the hand grips, I am going to be reusing the brake, although not the throttle control. So the brake we want to save, which I will tuck back down through in order to fish it through so that I can feed it back and hopefully remove it at the brake. Once the brake is out of the way, we'll be able to remove the handlebar assembly itself. It comes off with 4 simple hex nuts and 2 clamps, releasing it entirely. I won't be able to get the body off entirely at this point because I still got the brake cable attached, so we're just going to set it over to the side here while I figure out how to get the brake off in one piece because I don't want to have to cut it if I can avoid it. Unfortunately, as I'm about to find out, it's unavoidable. It's crimped at the very end, but I can save 99.9% of the cable, and there goes the body, completely separate from the frame. With the body free, Steven can get good access in to clean it. This is all the more important because he wants it painted about the same color as the car in the background there, which means we need to be sure and get all of the silicone and everything else that might be on it at any point off so the paint will stick properly. And might as well clean up the chassis and everything while he's got the cleaning materials out. Speaking of helpers, here's Arizona the shop dog in the background as I get ready to mount the controller underneath the chassis' main arm. I never used loud tools with the dog in the shop, but she got up here when I used the drill and I was curious if it bugged her, but then she kind of laid down behind me and didn't seem to care about it, so I'm guessing not. You never know what they can hear with their particular hearing range, but she looks pretty unconcerned. With that stuff out of the way, we have access to the chain guard, so we can open it and see what else is holding it together. There's apparently a bolt underneath that I can't see, but I think I can feel it, so let me flip this thing up on the... yeah, there it is. So we'll take that out with a little hex socket, and that should release this entire plastic piece. There you go. Now I got Steven holding the motor here, and the only problem is he forgot the holding part. With all the motor fasteners out of the way, I'll be able to get around to the other side and unloop the chain from the motor and then remove the motor assembly entirely. So I get Steven to hold it and then hand it off to me when I get to the side. Allow me to fish up this chain past the little idler gear there, around off the sprocket, and that should release everything. I think the wire is already free from all the electronics, and there you go, a bare naked chassis. I was hoping these motor mounts were standard in some way and that I'd be able to reuse some of the mounting holes, but only one would line up at a time, and I guess you're guaranteed that much. So I get out the straight edge and make sure before I start drilling my own holes. With the chain looped over it for a little more visual confirmation that everything is straight, I can make my marks as to where I want to drill. I've started each of these holes with a step drill, and then I'm going to go to 2 fixed sizes at the very end, the final of which I believe is 3/8, which is the size I need for the 5/16 nutsert. Now, the riv nut gun that I have does not go big enough to handle 5/16 steel nutserts, or riv nuts, whichever these are called, and so I went to my friend Jim to see if he had one that did. Instead, he gave me this little homemade contraption, which is a 3/8 nut with the threads drilled out and a 5/16 bolt. Run them together and watch what happens. It collapses down and grabs the mating surface. Unfortunately, watch all the metal shavings. So you don't want to be doing this with an impact, apparently, which I did not know until I reviewed this footage, went and Googled it, and learned, yep, do not use an impact. And so this is the case of do as I say and not as I did, because you're about to witness me do it 4 times, and produce copious metal shavings in the process, thereby proving that you should not, in fact, use an impact. Jim's little installer tool is great in that it uses a serrated nut, which usually grabs if you have enough down pressure on it, but I can't get that in all locations here, so I'm going to grab with a wrench. There you go. So fast forward to all 4 nuts are installed and we can drop the motor into place. It's held down by 4 5/16 bolts. Outside of some crazy luck, there's no way the chain's going to be the right length, which means I've got to take the chain off to lengthen or shorten it, and that means I have to take the wheel off, which means that through bolt has to come off. Then I can pull the wheel off. I'd never built a go-kart as a kid, at least not a powered anything, and so I'd never done one of these chains before. On bikes, I've used the installable link where you clip it on, but I wasn't going to trust this amount of power to that kind of chain. So I did it by hand, drove out the pins, and once you loop it around and mark it, you can find out exactly how long you need the chain to be. Now my problem here is that when you wrap the chain around, it doesn't terminate or it doesn't end with 2 of the small links together, such as I would like, so that I can just put a cover plate on and be done. As you can see, I'm like half a link out, which is really annoying. So I'm going to have to shorten or lengthen the mounting position of the motor in order to fix this. And so I'm not lucky enough to have a mill like my friend Jim, so I'm going to have him do the elongation of the bolt holes in the motor mount so that I can make it slide back and forth a little bit, which will give me room in order to mount the motor in such a way that I can slide it and take up or give more slack relative to the chain position. I am lucky enough to have a Steven, and he's in the meantime going to completely disassemble and clean the body, this time the underside as well, even though we're not going to paint the underside. It'll look nice. So here I am painting the actual body. I give it a light coat first, very light coat, and then I come back, give it another wet coat or 2. Steven also masked the headlights and laid down a couple tape stripes in the front so that when we peel it, we'll have white stripes revealed from underneath the red paint job. That's the plan anyway. It tended to bleed through a little bit, so we're going to get some white vinyl tape stripes and redo what you see there on the very front center, so it'll look nice. In the meantime, he's putting the body all back together. I'm back from Jim's, and this time with a bonus. He drilled the 4 holes in my 3-hole sprocket so that I can mount it on the Razor Quad 4-bolt axle mount assembly. And while Steven can do a lot of things, he can't cut metal as well as a bandsaw, so Jim cut this based on the paper template that I took in, actually cardboard. And now we can see if the motor will fit with my new mounting plate. And it looks like the answer is no. At least not with this here. So our next step is going to be relocating the suspension. My first attempt to gain more clearance will just be to move the hole back in its swing arc radius and then remount the shock. Well, it's not actually a shock, it's some kind of spring assembly. But we drill a hole and we'll be able to swing up the mount and remount it about ½ an inch back further, which should buy us somewhere between 1/4 and 1/2 inch more clearance to the motor. And indeed, it looks like we have enough on that side. It's still a little tight on the frame side, especially if you get a lot of suspension travel. But thanks to this mega zoom, you can see that there's actually a little bit of clearance between the gear sprocket and the body. And since the body doesn't flex here, it's mounted pretty rigidly immediately next to it. I'm not worried that it's going to move around a lot here, so this should be enough clearance for the chain. In order to mount the motor, we first need to mount the steel plate. In order to mount the steel plate, we need our welder settings. And it looks like arc strength of F and wire speed of 6.5 according to the Link Electric chart. So we'll set the plate in here, and then we'll mark and start scraping away what paint I need removed in order to weld properly. I'm going to use a 3M roll-lock disc, which is kind of like a red Scotch-Brite. If it's made by 3M, it probably is a Scotch-Brite, in fact. There we go. Now, I'm going to set a magnet on here so I can ensure these things are flush. Now, I would have to apologize for my welding on the best of days, but this is going to go really, really poorly. And I should notice much sooner than I do that my gas is not flowing. And that's why I'm getting all these horrible sparks, and I'm not getting a bead, and things just going really poorly. Okay, with a little off-screen re-welding and grinding and painting, it looks passably ugly enough to fit in with the factory side, which is also pretty ugly. With the motor dropped into place, we can make sure it's flush, tap it into final position, and then mark our bolt hole locations for where we need to drill. There's no good way to drill these in place, but if you flip the body up, you get pretty reasonable access to it. As before, I will start with a step bit until I work up to a reasonable size and then switch to fixed size bits that I know are the right size for the final placement of the nutsert. Then with the nutserts in place, I will again incorrectly use an impact to run them into the final location. The flange on the top of the nutsert raises the mounting surface by about a 32nd of an inch, which isn't a lot, but when you haven't got much to spare, it really drove it home and made it obvious that I have to make an alternative mount here to get this swing arm spring assembly out of the way. So with a kind of a split H-beam, I will now turn on the gas and tack this one into place. Even though I'm moving my tacks around here because I want things to stay pretty flush to the mounting surface, you can see light underneath there, which indicates to me that it lifted after the first tack. Again, this is not super important because I'm going to go back and weld it and it's going to be plenty strong enough to hold a go-kart swing arm. But even so, if you were doing something a little more important and demanding, you'd want to watch for that kind of thing. With everything secure in place so that it won't move around from heat as I weld it, I'm going to go ahead and finish, well, you can't really call it finish weld. I'm going to finish my welding of this piece. I've got friends that are professional welders, and watching me weld must make them feel kind of like I feel watching them install printer drivers, I guess. It's painful. By the way, these are nice comfy gloves, but they won't protect you from anything really hot. They're just good for sparks, and that's about it, I find. And with a coat of paint, here's the final mount. I was going to add a gusset going straight back to transfer the load to the back axle, but I really think this is going to be strong enough for the amount of load it has to take, so I'm going to leave it as it is. Let's then put our chain on and see where we wind up. I'll bring the chain around, use as much tension as I can, see where it lands. And fortunately, it lands in a position where I can now just flip the plate over and put the pin through, which is what I wanted in the first place. Pushing the pin through with the pliers works pretty well, and if you overshoot it, you can just tap it back with the hammer. Now, it's not as tight as I would like. There's more slack here, but you're supposed to have some. I'm not a go-kart guy, so it's not going to jump off the front motor. Maybe it's right, I don't really know. I'm still waiting on a proper 45 amp terminal block from Amazon, so in the meantime I've connected these with machine screws so I can at least test the mechanical side. I've also shrink wrapped them and electrical taped them. Well, hey, it works first time, albeit backwards, I see. Well, what if I give it more throttle? Arroz con polo! That is a lot of potential energy. Grab the dog. Run away, children. So to fix that little terrifying incident, I removed one more link from the chain, and we're going to take this outside, and we're going to try it in the safety of our driveway. Now I'll put it up on a jack stand here, and I'll chock the front wheels. It will be running in the reverse direction, so it will take off towards the neighbors if it all goes wrong. Note that I am quite far away, and I'm zoomed in with the camera because, again, I don't want to be anywhere near this thing with the amount of potential energy. I've gear reduced this as much as I possibly can, using a 9-tooth sprocket on the motor and a 74-tooth sprocket on the axle. That puts us at 23 miles an hour. And now we need some kind of serious chain guard to make this safe, and we need to figure out why the motor is running backwards and see if we can correct that as well.